the main objective of our study was to estimate the biomass of herring and mackerel schools using multi-beam sonars. The traditional tool for measuring fish with acoustics is the echo sounder. The echo sounder is basically one narrow acoustic beam, 7 degrees, that is looking downwards. In contrary, the sonars are not looking down, are looking to the side, and they are not only one beam, are many beams, 64 or 100 of beams. The low-frequency sonars are used by fishermen for search for fish. And some of the models can reach a range up to 8 kilometers. So it's quite impressive, the power that have this equipment to search for fish. However, sonars are not a standard tool in fisheries acoustics, although now in most modern vessels, research vessels, they have a sonar, but they are not used as a standard tool. Again, the standard tool is the echo sounder. And this work, we present a method to estimate the school biomass using acoustic backscattering data from a calibrated sonar. For making this work more complete, we also use real catches of mackerel and herring of individual schools to compare the estimates that we compute from the sonars. The novel research approach of this work was to use the acoustic backscattering data from a calibrated sonar to give us the fish density. Also, the sonar has the capacity to have, as I said, horizontal beams, but also vertical beams. Therefore, we are able to have an horizontal and also a vertical section of the school. So with this information, we can have a very good representation of the school volume. So we have one side is the fish density from the sonar and also the school volume. Previous studies in the 90s used also the sonar, but they didn't have available the digital data from the backscattering. So it was used mostly to have an estimate of the area of the school, and the information from the fish density was coming from the echo sounder. But the problem using the echo sounder is that to measure a school, you have to go on top of the school. And that, in some species and some cases, that could be a problem because the fish could react to the approaching vessel, and then your measurements will be biased. Also, with the echo sounder method, it's very difficult to hit the center of the school. So most likely you will hit the borders of the schools, and then the density of those will probably not be representative of the whole school. So as I said, the validation for these estimates were done with real catches. We were lucky to have a quota of 600 tons of fish every year during the duration of this project to catch target schools. So we were able to locate a school, decide if we're going to catch it or not, and then ask the fishermen to catch the whole school. So this ensures that the amount that we will get from the catch is reliable. There's no fish escape, or we catch maybe 2 schools. So we are certain that we have the best data to compare with our sonar estimates. This method presents how to use the sonars to calculate the biomass of single schools that can be used for both scientific and fishing purposes. For scientific purposes, we can have much more accurate estimates of single schools than using the echo sounders because of this sampling, larger sampling volume. And from the fishery point of view, this method can, if applied, can improve the estimates that currently are implemented in the commercial sonars. Now, the estimates that are available in the sonars are not so accurate, are mostly based on area. So they don't consider density or the volume of the school. That is what we are proposing with our method. So we are in talks with the sonar producers, and there's could be some chances that they will implement our method in their products. This method that we propose now we have presented for single school biomass, but also the methodology that we present can be used for other studies, like investigating the school behavior, school migrations, investigate the bias of the echo sounder blind zone is that when the fish is located too close to the sea surface, that the echo sounder is not able to measure correctly. And then with the sonars that we're looking horizontally, we can have information about that. But also we can use the sonar to study the fish reaction to an approaching vessel. And this also could be very valuable to validate the quality of the echo sounder measurements. With the knowledge that we have gained with this work, we're currently developing methods to do echo integration with the sonar data. So we can obtain now indices of abundance that can be compared with the standard measurements done by the echo sounder. And then we can compare both and in a way use the sonar to verify that the measurements from the echo sounder have no problems of bias due to the blind zone, avoidance, or even patchiness.